All right, this is 12-3, measures of central tendency and dispersion. Our objective is to find the mean, median, mode, and range. So most of you guys know what mean, median, mode is, but it's important that we review because it's been so long since we've messed with this material. So the means is the sum of your data divided by the total number of data values you have. It is often referred to as the average, and we use the mean to describe the middle of a data set that does not have an outlier. So mean works well when we have no outliers. The median is the middle value of the data. So you arrange all the data in order and then find the one in the middle. For a set containing an even number, the median is the mean of the two middle data values. We want to use median when we want the middle of a data set that does have an outlier. So when you have an outlier, the median is a better idea of what the middle of the data set is like. Lastly, in this section is the mode, is the data item that occurs the most times. A data set can have no mode when you don't have one number that occurs more often than another. You can have one mode when you have one item that occurs more than any of the others, or you can have more than one mode. We want to use mode when the data are non-numeric or when choosing the most popular item. An outlier is a data value that is much greater or much less than the other sets of values. So let's look at how we fuss with this data. In this problem number 1, we want to know what the mean, median, and mode are for the bowling scores, and which measure of central tendency best describes the scores. So to find the mean, we take all of our bowlers and add them all up, their scores, and since we have 8 bowlers total, we divide by 8. And when we do that, we get 122. The median is the data value in the middle. In this case, we have 8 data values, so the middle is in between the 4th and the 5th term. So to find this data value, we have to add those two together and divide by 2. So our median is 111. So our mean is 122, our median is 111, and our mode is the one that occurs most often. When you look, 104 is the one that occurs more than anybody else. The issue is this data value here. He is an outlier. We had a bowler that bowled way above what the other bowlers were able to do, so he gets to be called an outlier. Now we look at our little chart, and it says use median to describe the middle of a data set that does have an outlier versus mode when the data are non-numeric or when choosing the most popular. So because we know we have an outlier, we had to look between, do we use the median or do we use the mode? We have numeric data, and we're not looking at most popular. So we know that the median best describes the data. All right, so consider the scores from problem 1 that do not include the outlier. 189. So we're going to take 189 out of our calculation. And what measures of central tendency best describe the data? So instead of the outliers, we're going to have 104 plus 117 plus 104 plus 136 plus 109 plus 113 plus 104. And we're going to divide it by 7 data values. So the data is 100, the new mean is a 112. So which measure central tendency best describe the data? The mode is still going to be 104, and then the median is now, let's take a look at what our median is going to be. So when we line them all up, the median, because 1, 2, 3, it's 109. All right. So the median is the middle value, and it's to describe the middle of the set of data that does have an outlier. So in our case, the mean is going to be the best number without the outlier. All right, you can use an equation to find the value needed to achieve a given average. So say you, this really works well when you're calculating grades, and as we're getting to the end of the semester, you guys can do this grade calculation as well. Let's look at the example. Your grades on 3 exams are 80, 93, and 91. What grade do you need on the next exam to have an average of 90 on the 4 exams? So say you want to get an A, we want 90 degrees. So here you got data value plus data value plus data value plus your unknown next exam. And you want to divide that by the number of exams there are. In this case, it would be 4. And you want it to equal 90. So then you add all these little numbers together. You get 264 plus x. All divided by 4 equals 90. So in this case, we're going to multiply each side by 4, and we get 264 plus x equals 360, and we're going to subtract 264 from both sides, and we get 96. So you must get a 96 on your next exam for you to have an average of 90. So let's do that again. The grades in problem 2 were 80, 93, and 91. What would the grade on the next exam have to be in order to have an average of 88 on the 4 exams? So we're okay with a B+. All right, so we do that same process. Multiply by 4. We're going to add these guys together. All right, when we do that, we get 264 plus x equals 352. So we want to take away the 264 from each side. That's 8 and 8. So we would have to get an 88 on the next exam to get an 88 average. Reasoning. If 100 is the highest possible score on the 4th exam, is it possible to raise your average to 92? So let's do a little test on that. So if this were to equal, what were that, if we make this 100, then $264 plus 100 divided by 4. The highest we can get is a 91. With a fourth test score of 100. Boo. So no, it's not possible. All right. A measure of dispersion describes how dispersed or spread out. So a measure of dispersion describes how dispersed or spread out the data values are. The range of a set of data is the difference between the greatest and the least data values, and it's a way we can figure out dispersion. So let's look at finding the range. The closing prices in dollars of 2 stocks for the first 5 days in February are shown below. What are the range and mean of each set of data? Use the results to compare the data sets. So stock is 25, 30, 30, 47, 28. We take the highest and the lowest and subtract them. And that's the range. We know how to calculate the mean. And so let's do that with the second one. Take the lowest and the highest and subtract them. And then you find the mean. Both set of stock prices have a mean of 32. The range of prices for stock A is 22, and the range of prices for stock B is 8. Both stocks have the same average price during a 5-day period, but the prices for stock A were more spread out. So we're going to do the same thing. For the same days, the closing prices in dollars of stock C were 7, 4, 3, 6, and 1. The closing prices in dollars for stock D were 24, 15, 2, 10, and 5. What are the range and mean of each set of data? Use the results to compare stock C with stock B. So let's do C's calculations. So we want the range and the mean. So the range is the smallest one, so that would be 1, and the largest one subtracted, so that's 6. And the mean is these 5 items added and divided by 5. And when we do that, we get 4.2. So for D, we want the largest and the smallest, and we're going to subtract them. Is 22. And then the mean is all 5 of these guys added together and divided by 5, which is 11.2. So stock C has a smaller range of numbers. It only varied 6 values, while stock D has a range of 22. But stock D has a higher mean value than stock C. So stock D has a higher mean and range than stock C. All right. Go on to our next part, finding measures of central tendency and ranges. So the results of a survey on the number of televisions in students' households are shown in the plot line. So we've got 1 through 5. Calculate the mean, median, and range of the data set. So the mean, when you added them all together, now look at this. We have, when we're looking at our data, we have 2 number ones. So we're going to go 2 times 1. Wonder how many households have 2 televisions. There are 4 households with 2 televisions, so it's going to be 4 times 2. There's 6 in the 3 column, 4 in the 4 column, and 2 in the 5 column. So when you're looking at the mean, you, instead of adding 4 2's, you can just go 4 times 2, and it's supposed to simplify your calculations. For the median, you still have to list them out, so that's where all these numbers come from. Now since you have an even number of data, there are 2 values in the middle, but thankfully when I add them together and divide by 2, I still get 3. Mean is 3, median is 3, and the range is 5 minus 1, which is 4. How can you tell from the graph that the mean and the median are equal? When the graph is symmetric, the mean and median will be equal. So let's do that on our own. The line plot shows the number of students in each homeroom at Jefferson High School. Find the mean, median, and range of the data. So my mean is going to be 4 times 19 plus 5 times 20 plus 6 times 21 plus 2 times 22 plus 2 times 23 plus 1 times 24. All divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 data values. So you get a mean of 20.8. The median is when you write all the numbers down, 20, 20, 20, 21, 6 times, 22 twice, 23 twice, and 24 once. If I have 20 data sets, then I go 1, 2, 3, 4, 6, 7, 8, 9, 10. So the median is between 21 and 21. When I add those together and divide by 2, I get 21. All right. Our mode, oh, we don't need it. Our range, just while I was rolling, I've thrown in mode. Our range is our smallest and our biggest. So that is 24 minus 19, which is 5. So B says, how can you use the line plot to determine whether the mean and median are equal? So if the mean and median are equal, then you're going to have a symmetrical frequency distribution. So in this case, because my data is so skewed, I know my median and my mean are not going to be equal. All right, so let's roll down to here. And we are going to see the results from the third class C are shown here. Is the mean for class C greater than or less than the mean for class A? So looking at our scores between class A and class C, the mean is going to be, it's going to tend more towards this side of the graph, whereas class A is going to be 3.5. So class A wins. Is the mean for class C? Class C is less than. Is the median for class C greater than or less than the median for class A? Well, class C is also going to be less. How can you tell which data set has a greater mean by comparing the graphs? Just by looking at the graphs, because your data is heavy on this side, everything is all your numbers are going to be lower.